Hello, in this video I will integrate a partial fraction with a distinct quadratic or a higher degree factor. Okay, so over here we got to integrate 3x minus 2 all over x minus 2 all over x squared plus 4 dx. So we do have this is a non-repeating quadratic, and then we have a linear, right? So as you can see, this is a linear and it's non-repeating. And then this is a quadratic non-repeating. Okay, so first I'm going to decompose it. So this, you can rewrite this as 3x minus 2. Okay, so this would be decomposed as a over x minus 1 plus uh, x squared plus 4. So this is bx plus c. Okay, so in the previous problems, uh, why is this a bx plus c? Well, let's look at here. This has a power of 1, so this obviously has to be x to the 0, right? The power on the bottom has to be bigger than the top, so that's why we just have an a here. Now, over here, our highest power is x squared, so this has to be a power of 1, and then when you have to go down, so now you need a constant, so that's why we need a plus c here. Okay, so we got to figure out, this time we got to figure out an a value and a b value and our c value. Okay, so what are we going to do next is we're going to multiply all three sides by the LCD. And what do you think our LCD is going to be? It looks like it's going to be, our LCD will be x minus 1 times x squared plus 4. Okay, so if I multiply all three sides by that, what do we get? So when you multiply here, everything, the bottom cancels, so you're just left with 3x minus 2. Over here, when you multiply that, the x minus 1 cancels, so you're just left with a, and then x squared plus 4, plus, over here, what do you see that cancels? The x squared plus 4 cancels, so you're just left with x minus 1, and then you're also left with the bx plus c. Okay, so how am I going to do this? Well, what I would do first is I wouldn't plug in an x value. What I would do is FOIL it out and then connect it with the left side. So what do I mean? So let's first FOIL out the right side. So this would be, when you FOIL this a out, this would be ax squared plus 4a. And then over here, when you FOIL this out, this would be bx squared. And this would be negative bx. And then this would be, well, this would be positive cx. And then this would be negative c. And then over here you have 3x minus 2. And then what I would do is kind of collect like terms. So like, even though you can't really combine them because they're, what I mean is like, get all the highest powers to the one side, medium powers on one side, except in the constant. So here I have let's get all the power twos on one side. So we have an ax squared here, and then bx squared there, and that's all I see. You can't really combine them because this is a letter A, this is a letter B, but you can just, group them. And then let's combine the x's. So I see a negative bx here and a positive cx there. Let's just put it all together. You can't combine them because this is a b and this is a c, but they both have an x. And then the next one is our constant. Our constant is, or our power one, not constant. Our power one is a 4a and a negative c. And then on the left, it's just 3x minus 2, right? Okay, and then what we'll do is what I'm going to do is like kind of connect it with the left side. So starting with the highest power, ax squared plus bx squared. On the left side, I don't see a power 2, unfortunately. So you can set it up. So you're going to have to set it up as, let me figure, 0 equals to ax squared plus bx squared. And then over here, the negative bx plus cx, this is a power of 1. So on the left side, I see a power of 1 of 3x. So you're going to set it up as 3x equals to negative bx plus dx. And then the next one is the 4a minus c, or the constant. So that is related to negative 2. Okay, so now we got to figure out from this, we kind of have to like set up a system of equation. And let's look here. 0 equals to ax squared plus bx. I could get rid of the x squared by dividing everything by x squared, including the 0. So this is 0 equals to a plus b. And then over here, what I could do is get rid of the x's because they all have an x. So I'm going to divide everything by x. So this is 3 equals to negative b plus c. And then over here, negative 2 equals 4a minus c. Can't really do much. So what would I do next? Okay, so we have our kind of like our system of equation. And what I'm going to do is just kind of like get a variable by itself. And so I'm going to use the system equation for right now, and I am going to solve for c. So to solve for c, I'm going to have to add b, add b. So you get 3 plus b equals to c, right? And what I'm going to do is substitute that value into this. So it's going to be negative 2 equals to 4a minus my c value, which I can just substitute as 3 plus b. Okay, so that's 4a minus 3 minus b, right? Negative 2. And what would I do next? I'm going to create a system of equations. So what I would do is on this one, I'm going to get all the constant on one side. So I'm going to add 3, add 3. So this is going to be 1 equals to 4a minus b, right? And then I'm going to create a system equation with this one. See how they have an a and a b? So that's what I'm going to do. So this is going to be 0 equals to a plus b. And as you can see, when you don't have to multiply it by number because if you add them up, what cancels? The b's, right? So I'm just going to add them up vertically. 1 plus 0 is 1. 4a plus 1a is 5a. Negative b plus b is 0. And then solve for a, so I'm going to divide both sides by 5. So I get a equals 1/5. Okay, I'm going to box it because I'm going to use that value. So now if I know what my a value is, I can substitute it back here because I could figure out my b value, right? So it's 0 equals to a, which is 1/5, plus my b value. And go ahead and solve for b. So yeah, I should just subtract 1/5. So I get negative 1/5 equals to b. Okay, so my b value is negative 1/5 and my a value is positive 1/5. That kind of makes sense because when you add them up, it should equal to 0. Now what I'm going to do is solve for c, since I know my b value, and I'm going to plug it back into, I guess here, this would be fine. So it's 3 plus my b value, which is negative 1/5, will give you your c value. So I'm going to solve for, what I would do, maybe get rid of the fraction by multiplying all three sides by the LCD. So we have a 1, a 5, and a 1, so my LCD will be 5. Go ahead and multiply all three sides by 5. 5 times 3 is 15. 5 times negative, well, that cancels, so you're just left with negative 1. And then don't forget about the c. 5 times c is 5c. Okay, 15 minus 1 is 14, equals to 5c. Solve for c, so you're going to divide this by 5. So each c equals to 14/5. Okay, so I know my a, I know my b, I know my c. Now we can uh, write out our two integration. So it decomposes as what we said it was. So our a value is the second a value is it is 1/5. So you can just replace a with 1/5, and then over here my b value is negative 1/5 x plus my c, which is 14/5. So it looks like a mess. Don't worry, we'll fix it. So here, let me show you. This decomposes as, so my a value is 1/5, so it's going to be 1/5 over x minus 1 plus my b value, which is negative 1/5 times it by x plus my c value, which is 14 14/5 all over x squared plus 4, and this is all times it by dx. Okay, what can I do next? Let's you could break it into two integration, right? Now let's simplify this. What do we have? It's a complex fraction, right? So you can say 1/5 divided by x minus 1 over 1. It's a complex fraction, so I can do the bracket, and I'm going to multiply both sides, the numerator and the denominator, by 5. Okay, so 5 times 1/5 just becomes 1. 5 times x minus 1, that's just going to be 5 parentheses x minus 1. Okay, so this integration just breaks down to this, and then don't forget dx plus, now how are we going to do this? Okay, so we have a complex fraction, so let's kind of like fix the numerator. So negative 1/5 times x, that's really negative 1/5 x. And then you have 14 plus 14 fifths all over x squared plus 4. Uh, and then we have to times it by dx. But let's kind of let's simplify this. Since they're both in the denominator 5, you could just say rewrite that as negative 1x plus 14 all over 5, because they both have a denominator 5, all over x squared plus 4. So now we have a complex fraction. This is my numerator, and this is my denominator. So what we can do is do the bracket method just like this one. So over here, this denominator has a 5. Over here, this denominator has a 1, so the LCD would be 5. So you're going to multiply both numerator and denominator by 5. So 5 times this, the 5's cancel, so you're just left with negative 1x plus 14. And then on the bottom, it's 5 times this, it's just 5 times that, right? I'm not going to FOIL it out, I'm just going to leave it like this. So uh, this whole thing, when simplified, will be simplified as negative 1x plus 14. And then you have 5 parentheses x squared plus 4 dx. Okay. Then what would I do next is start integration with u substitution, right? So let's start with this. How would I integrate this? Well, 1 over 5 is a constant, right? I could just take that out. So now you have 1 over x minus 1 dx. And how do I integrate 1 over x minus 1 over x minus 1? By doing u substitution. And our u is going to be x minus 1. And then my du would be the derivative of x is 1. And then you have a dx. Good. I don't have to take anything out. It comes out nicely. So that would be 1/5 over 1 over u. And then you're going to replace 1 dx with du. Okay. And we know that the integration of 1 over u is ln. So this will be 1/5 ln of absolute value of u, which is x minus 1. Okay. Now, how we got to integrate this? So let me rewrite it. What could I do? What I would do, this one is a little bit tricky. I could break it into two different integration or two different fractions, right? So that's what I'm going to do. This whole thing can break it down into two different fractions. It'd be broken down as negative 1 over x, 5 over x squared plus 4. So I'm breaking it down into two different fractions. And then this would be plus 14 over 5 x squared plus 4. Okay, so I'm going to break it down into two different integration. I know that's weird. You have to break it down more. So now we have two more integrations we have to do. So let's start with this one. Is there anything I can do? Yes, I can first factor out the constant, which is -1/5. And then you have x over x squared plus 4 dx. And over here, what can I do here? I can take out the constant 14/5. It's 1 over x squared plus 4 dx. Okay, so what should I do here? Can I do u substitution? Yes, I can. My u would be x squared plus 4. So my du would be 2x, and then the derivative of 4 is 0, so it's just dx. And unfortunately, I have to get rid of this 2 because I only have an x and a dx. So how do I get rid of that 2? By multiplying both sides by 1/2. So it's 1/2 du, and then on the right, 2 times 1/2 is x dx. So it's going to be x squared plus 4 is u, and then you're going to replace x dx with 1/2 du. And don't forget, you still have a -1/5. And what you could do next is 1/2 is a constant, so you could take it out. This would be, so 1/5 times 1/2 is -1/10. And then you have 1 over u du. Now can we take the integration of 1 over u? Yes, it is the ln of u. And our u was x squared plus 4. And then we also had this -1/10. And then over here, don't forget, this still comes down as 1/5 ln of x minus 1, absolute value of x minus 1. Now let's do the third part. What is the integration of this? U substitution will not work. It's actually a special one. It's like the tan inverse. So 1 over x squared plus 4 dx is a special one. It's 1 over n, and then arctan or tan inverse of x over n plus c. So what is our n value? It's related to this 4. So our n value is not 4, it's actually 2, because it's 2 squared, that gives you 4. So our n value is 2. So it's 1 over 2 tan inverse of x over n. So our n value is 2. And then we also took out, remember we took out a 14/5. So 14/5 times 1/2 is 14/10. And then 14/10 can be reduced by 2. So that's 7/5 tan inverse of x over 2. Okay, so my final answer will be, let me write it out nicely, 1/5 ln of absolute value of x minus 1 minus 1/10 ln of absolute value of x squared plus 4 plus 7/5 tan inverse of x over 2 plus c. And that's it. That is your final answer. Yeah, this was a long one, a longer example of all the work. So this was a partial fraction with a non-repeating linear and a non-repeating quadratic. Okay, I will stop here.